lesson 11, we're going to look at the absolute value function and its graph. So first of all, we have this definition of the absolute value function. So the absolute value function f is defined by setting f of x equal to the absolute value of x for all real numbers. Another way to write f is as a piecewise linear function. So we can rewrite this f of x equals the absolute value of x as f of x equals negative x when x is less than 0, and f of x equals x when x is greater than or equal to 0. So we can define it as two parts. So the first thing we're going to do is let's go ahead and let's graph this as a piecewise function, and then we'll graph it as this absolute value function, and we'll see how the graphs are the same. So if you look at this first part, we have a piecewise function with two parts. So I'm going to go ahead and I'm going to graph this just like I would any other piecewise function. So my first restriction is x has to be less than 0. So I'm going to start my table at 0 and then all of the numbers less than 0. And at 0, I'm going to have an open circle because x is strictly less than 0. So then let's go ahead and fill in the y values. So we plug in, so negative 0, we don't really have a negative 0, so we just call it 0. Negative, negative 1, so negative times negative 1 is going to be a positive 1. Negative times negative 2, if I plug it in, is going to be 2. And a negative times negative 3 is going to be positive 3. So basically I'm taking each of these negative numbers and they become positive because I'm multiplying by a negative. So I can go ahead and I can plot these. So at 0, 0, I have an open circle. Negative 1, 1. Negative 2, 2. Negative 3, 3. And this pattern's just going to repeat. So basically what I end up with is I have a line on the left-hand side here. And I can go ahead and I can have that arrow going to the left because this line is going to just keep on continuing for all negative x values. So now I'm going to go ahead and graph the second part of this. So the second part, I look at my restriction. My restriction is x is greater than or equal to 0. So again, I'm going to start at 0, but this time at 0, I'm going to fill that point in because I can include 0 as an x value. And x has to be greater than or equal to 0. So any numbers bigger than 0, I'm going to plot. So when I plug in 0 for x, I get out 0 for y. I plug in 1, I get out 1. I plug in 2, I get out 2. And when I plug in 3 for x, I get out 3. So we have 0, 0 is now going to fill in that open circle from before. 1, 1, 2, 2, 3, 3. And this is just going to keep on going. So again, I'm going to connect these points, but I'm going to have an arrow to the right-hand side because this part of my graph is just going to keep on going. So basically what we end up with is this V shape. So this piecewise function is actually the same thing as the absolute value function. And here's why, because if you take the absolute value of any number, you're always going to get out a positive number. So for example, if I take the absolute value of negative 6, my answer is positive 6. So if you look at the graph, when x is negative 6, I get 6. If you take the absolute value of positive 6, you get out 6. So the absolute value, we know, anytime you take the absolute value of a negative, you get out a positive. So piecewise, we have to define the negative numbers as a line with a negative slope. And on the right-hand side, in the positive numbers, we define the part of the piecewise as a positive slope, a line with a positive slope with a y-intercept of 0. So let's just make sure. So looking at number 2 here, it's saying, well, now if we look at g of x, which is the absolute value function, so this is the absolute value function. That's what those bars stand for, take the absolute value. If we actually create a table of values, let's just make sure that we actually get out the same shape. So basically, if you start with this absolute value, you want to take some negatives and some positives. So let's say I start at -3 and go all the way to +3. So if you take the absolute value of -3, it's going to equal +3. You take the absolute value of 2, you're going to get out +2. Absolute value of 1 is 1. Absolute value of 0 is 0. Absolute value of positive numbers, so let's say I take the absolute value of 3, is still going to be 3. So all of these numbers are just going to be the same. So basically, if you go to plot these points, we have -3, 3, -2, 2, -1, 1, 0, 0. I'm just plotting all those points I just came up with. I get out this exact shape. I get that same V shape. So this graph is really the absolute value function. So this is a special case where you can have this one time, you have this piecewise function. So you have two lines, one with a negative slope, one with a positive slope. It's the same thing as the absolute value function. So this is a special case for a piecewise function. It actually gives you this absolute value. So one last thing here, a couple of things when we're looking at the absolute value function. This is kind of like now an additional one of those parent functions. Remember we talked about x squared, x to the third, x, all these different parent functions. This is now an additional one, the absolute value function. And instead of defining it as a piecewise function, this is the one time that you can just define this using a single function, even though it's really two separate parts. It's two separate lines. So another thing to look at is this graph is always going to be symmetric. So whenever you're looking at the absolute value function, it's going to be symmetric because I could take this part and I could reflect it over this vertical line and it would match up with this part. I have a vertex, so it's very similar to a quadratic where the vertex is always halfway between any of these other points. I know that this is a function, however, it is not a one-to-one function because if I draw a horizontal line, my horizontal line hits twice. So I have two different, or for two different x values, I have the same y value, so that's why it's not one-to-one. And then the last thing I want to look at is the domain and range of this function. So the domain is going to be all real numbers. You can plug in any number you want into the absolute value function. So if you look, this keeps on going left and right. This graph will keep growing wider. However, the range is going to start at 0 and go to positive infinity. So starting at 0, including 0, going to positive infinity. You'll never take the absolute value of a number and get out a negative number, so it should always be positive. So it's always going to be up in this top half of the graph.